Hello explorers and welcome to another video. Today we are doing another puzzle from the advent of code. It's day 10. And let's start by reading the problem. So let's switch over here to this screen and read up here. Patched into the aircraft data port, you discovered the weather forecast of massive tropical storm before you can figure it out whether it will impact your vacation plans. However, your device suddenly turns off. The battery is dead. You need to plug it in, and there's only one problem. The charging outlet near your seat produces the wrong number of jolts. Always prepared, you make a list of all the joltage adapters in your bag. Each of your joltage adapters is rated for the specific output voltage, your puzzle input. Any given adapter can take an input of 1, 2, 3 or 3 jolts lower than its rated and still produce its rated output voltage. In addition, your device has a built-in voltage adapter rated for 3 jolts higher than the highest adapter in your bag. If your adapter list were 396, your device built-in adapter would be rated 12. Treat the charging outlet near your seat as having an efficient voltage of 0. Since you have some time to kill, you might as well test all your adapters. Wouldn't want to get to your resort and realize that you can't even charge your device. If you use every adapter in your bag at once, what is the distribution of voltage difference between the charging outlet and the adapters of your device, for example? And then they have something here with a lot of examples, and what they are looking for is the differences in 1 jolt and the differences in 3 jolts, and then they want you to multiply those answers. So what is the number of 1 jolt devices multiplied by the number of 3 jolt devices in difference? So that's what we need to figure out, and here we have a small list of devices. So let's jump over to the code here, and I copy pasted from the last example here. So let's take the puzzle 10 test, and this time I actually want to have an integer list here. I want to look into this test here. I guess that the numbers here can't be that large. So integers are just fine here. And then we will take integer parse int of this line. Because if we have a list of numbers, we can actually sort it. So we sort this using a comparator a, b, and if a is larger than, let's see here, how is the sort algorithm? Or we can just do an integer compare, I believe, and we just remove this. I think something like that. Let's then take A and B and do integer compare A and B. Could that be what? Replace lambda with method reference. Like that. That's how you write it. So if we do like that and then do numbers s out and stop here, we should have a list of sorted values in our little array here. The wrong example. Like that. And we see that we have a sorted array of numbers here. So now we just need the differences. And I'm gonna be a little bit safe and take up to 10 in difference. hopefully we will never get that high. But if we do a for loop of a value 0 less than numbers size -1, and the reason we do -1 is that we need to look one ahead as well. So if we take this numbers and get the next number and divide minus the numbers get this number, we should get a value, and that is our difference that we put in here. So we add to that. Then we need to have arrays fill. So we take this int array that we have up here, diff, and fill that with zeros. So we are sure that we get zeros. And if we run this, we should have an array of differences here. So we have 21 ones and 9 threes and nothing else. So that looks very nice. So if we do like this, diff 1 times diff 3, what is the result of that? Let's see here, that's 189. Let's go back here and see. And we got 10 differences of, and that's because we have, let's see here. I think we are missing 1, and we are missing 1 in each of these, and that's because we have the difference of the first one. So if we do numbers get 0, so that's one difference, because that's from 0 to that specific number. So that's the first one we need. And then we need at the end here also to add 1 3 as well, because that's the last one to our device. So now we get 220, and I believe that should be the result of the first one here, 22 and 10, yeah? So now we can take this and run it on our full example and see what we get. If this is the answer, 2059. Let's add that. That's the right answer. You get a gold. You get a gold star. I get a gold star. Everybody gets a gold star. Oh, that was very belated. Let's go back here and see what the next thing is. To completely determine whether you have enough adapters, you need to figure out how many different ways they can be arranged. Every arrangement needs to connect the charger outlets to your device. The previous rules about adapters can successfully connect still apply. The first example above, the one that starts with 16, 10, 15, supports the following arrangement. So that's one way to do it. Okay. The charging outlet of your device built-in adapter are shown in the parentheses. Given the adapters from the first example, the total number of arrangements can connect the charging outlet to your device is 8. The second example above one, it starts at 29 and has as many arrangements as there are. Here are a few. Okay. In total, the set of adapters can connect charging outlet to your device in 19,208 distinct arrangement. You glance back at your bag and try to remember why you bought so many adapters. There must be more than 1 trillion valid ways to arrange them. Surely there must be an efficient way to count the arrangement. What is the total number of distinct ways you can arrange adapters connecting the charging outlet to your device? Oh, Jesus. So this is a challenge. Yeah, so you can do it either with 1, 2, or 3. So that means that on any place where you are, you can add either 1, 2, or 3 and get another path that you can go down. And you need to end up at the highest puzzle value. So only those that connect to your device at the end are valid ones. I think we need to create a puzzle 10B here. So we can have that. We have the numbers here. So that's a way. There is a way to count this with permutations, I guess. So you can figure it out via counting and a bit of math, if you like. Another way is to fill arrays with more and more different paths. So that's a way as well. We only need to count each of them. But I guess that you can check out how many ways each number is given. So if you go through the list and see how many different ways can I permutate this value. Because we start at 0, so we only have one way from 0, right? Now we have multiple ways from 0 as well, yeah. So if we have a value, we want to see how many of that value can be so let's create a function here, public how many per value. So like that. And it doesn't need to be that efficient, but we give it a value, and we also give it the list of integers like that. And let's give that a name as well, list. So for this list, integer I list, if this integer is equal to val plus 1, then so this is 1 value. If that's true, then we will see. Then we get 1 or 0. So int number of ways 0. So here we will have number of ways and increment that by that. And we do that for the 3 different ways it can be. So we go through the full list, which is not required, but we do that. And we get the number of ways that permutation can happen. And if we do that, and we first off do this long number of ways, okay, so it needs to be static as well, static. So here get, what did I call it? How many, how many per value? So like that, and then we give it numbers and 0. So that's the first starting point that we have. Next up, we have a for loop with all the values within this numbers list. And it's sorted, but that's not really required. Integer I in numbers, and then how many ways per value, and then I, and number of ways. So we do times that, and then we don't need to do it with the last value, because that's 1. So that's only one way we can connect to that charger. So that's not an extra permutation, I guess. So that's the only way we can get there, the last mile, so to say. So that's not an extra way. So this is the number of ways this could be taken. Hopefully this is the correct amount. So let's run this new example here. We get 0, so that's not the right one. So let's see here. If we go to the first value here, so we have the number 0, and value plus 1. Let's see, the I is 1, so here it's true. So number of ways should be 1. Okay. Then 2, so then it's 2, and 3. So this should return 3 ways. The number of ways is 3. Is it that the value even goes over the amount for an... Yeah. So we have the problem that the long is not long enough. So big integer is big integer value of, and then we get that. And then we will take this big integer and multiply it with this value here, which is a big integer value of, like that. And there is a toString for this one. So let's see if we get a huge number this time. No, we get 3. This is so strange. Let's try this again. See if we get any changes here. So number of ways. Okay. So we don't do the multiply at all because it returns a value that we need to assign. Oh my god. And now we get 0. Oh, this is annoying. Let's see here. So now it actually does the multiplication and it goes up a lot here. So why does it end up getting very small at the end here? 52, 53, 54, 55. So that's the last value, right? So why do we get 0? Okay, so the last value gives us 0, which is not okay. So let's say, for simplicity, that if this function were to return 0, we will return 1 instead, because multiplication with 1 is just fine if this is equal to 0, return 1, else number always. So now we should get a huge value here. Yeah, so that's a large value. Let's see if that's the correct input here. Not the right answer. Your answer is too high. If you're stuck, make sure you're getting the full input data. There's also some general tips on the About page. Okay, so what did we do wrong here? Because the device could connect in one of 3 ways. Can take input of 1, 2, or 3 jolts. In addition, your device has a built-in voltage of 3 volts higher. So let's see here. They are actually doing all of these different arrangement. So let's see here. The old example that we had should give us, so if we add the test example here, that should give us that value, but it gave us a much larger value. So that's not okay. And then I will leave it here, because I'm not going to solve this one. I'm not really sure what I've done wrong, and if you have any suggestions, leave those in the comment section down below. If you like this video, give it a like, share it with your friends and colleagues. If you had a good way to solve this and think in a different way than I do, please add some code in the comment section as well. If you haven't subscribed yet, please do that, and I really hope to see you in the next video.